So DFDB is a way to solve 4C cycle cases during LSD that can be done almost without any pause, which is why it's so useful compared to BU recognition, and a lot of fast Rouxers use them. The way it works is that you recognize the cycle case with the DF edge and the DB edge. In this case, since we're using blue and green blocks, our DF edge piece would be white-red, and our DB edge piece would be white-orange. And both of them are always on the top when you have a cycle case. That's our DF piece, DB piece. So the first thing we want to do to use DFDB is to set up the M2 insert that you would usually set up to complete 4B. So just like this, the M2 insert. That solves 4B. So you want to just put it at the step before it. After you've done that, it is guaranteed that one of your DF or DB pieces would be aligned with the center somewhere. So in this case, my DF piece, white-orange, is aligned with the center at the front. And now there's two major cases. The first is matching center case, and the other is non-matching center case. Here we have a matching center case because our DFDB piece on the center here is aligned, is the same color as the center that it's adjacent to. So here it'll be a matching center case. Let's see if I can set one up. If it's like this, so before the M2 insert, the DFDB piece that is touching the center does not have the same color. That would be a non-matching center case. And the two cases have different ways of solving them. So yeah. So first we're gonna go through how to solve a matching center case. So once you've set up your M2 insert, you realize it's a matching center case, you're gonna do M2 and then notice where this aligning the DFDB piece is gonna go. So after I do M2, it's gonna go to the back there. So after doing that, we have another DFDB piece left over here. In matching center cases, what we want to do after the M2 is to turn once the U layer such that this piece is opposite, this DFDB piece is diagonally opposite to the previous DFDB piece that we already moved. So here we already, so this is our first DFDB piece. We already did an M2 to move it to the back here. So we want to move this so that it's diagonally opposite. And that would be a U move. So now they're diagonally opposite. Here it's a bit different. So we set up our M2 insert. We notice it's a matching center case. And after we do M2, this DFDB piece still goes to the back, but this time our other DFDB piece is on the left here, and we still want to move it opposite to that. So in this case, it would be a U prime instead of a U. Either ways, once you've moved this, once you did the M2 and moved the DFDB piece opposite to it, you're gonna just complete the solve with M prime U2 M. Yeah, that's it. Sometimes though, after you put one of the DFDB pieces to the back and put the other DFDB piece opposite to it, you're gonna notice that the usual M prime U2 M is not gonna solve it, and we need an additional U2. So yeah, this does happen sometimes, and the way I distinguish them is just that this piece is different. M prime U2M, and we need an additional U2. Yeah, just watch out for these special cases. In addition, once you set up the M2 insert, sometimes you will notice that the DFDB piece that is aligning with the center is on the back. So here we have it on the back. Now when this happens, we do the same thing. We just do the M2 insert, and that would place the DFDB piece to the front. So we're still going to move the other DFDB piece, which is here, opposite to it. So like that would be a U prime. So now they're opposite. And once we're done with that, we're going to use a different 3 mover to solve the cube. This will be M prime, U2, M prime. And now the same thing applies here. Sometimes once you completed that, so here we're going to do M2, move this to the opposite, and we're going to notice that M prime, U2, M prime is not going to solve it. We're going to need an additional U2. The way I distinguish them is just once you completed putting the DFDB piece opposite to each other, they're going to look different this way. This would be M prime, U2, M prime. This would be M prime, U2, M prime, U2. Another case that can happen is when you do the M2 to insert to move this DFDB piece to the back, you would have a color that connects with the other DFDB piece. So here, let me do that. M2, put it on the back. And now we have a color that connects with our other DFDB piece. Both are white. We're going to proceed doing the same thing. Put this DFDB piece opposite to that one. But now the way we solve this is a bit different. We need to use M, U2, M. And yeah, the same thing goes for this. Sometimes if you do that, put that DFDB piece at the back, the colors connect, move it to the opposite. Here we'll have to do an additional U2 to solve it. We have one more case with our DFDB piece aligned at the back here. So this is the previous one that we talked about. The way I distinguish them is after doing the M2, our previous case is gonna have the colors of the other DFDB piece with the center aligned. Yeah, that's our previous case. So when you do the M2, set them up to each other, opposite to each other, there'll be an M prime, U2, M prime. For this case, however, when we do the M2, we would know that these two colors don't match. The remaining DFDB piece in the center don't match. When this happens, after setting them up opposite to each other, it's going to be an M, U2, M prime instead. And for this, the same additional U2 case could happen. So after the M2, set them up opposite. After doing the M, U2, M prime, we would need an additional U2. So now we finished all the matching center cases. Now we're going to look at the non-matching center cases when the DFDB piece that is aligning with the center does not have the same color after setting up the M2 insert. So here we don't have the same colors. So the thing different with non-matching center cases is after you do the M2, you're not trying to put this opposite to that DFDB piece. Instead, you're always gonna try to solve the corners first. So like we do the M2, we're gonna solve these, that would be a U to solve them. Yeah, so that's the first thing you want to do. No matter which non-matching center case it is, you're always going to solve the corners. There's also going to be two main subcategories where after you solve the corners and the DFDB pieces are opposite to each other. The other case is when you solve the corners. So here's our DFDB piece, put it at the back, and we solve the corners. The DFDB pieces are opposite, stacked on top of each other. So that's the main way to distinguish between the two major cases. Whenever you have a non-matching center case where after you solve the corners, the DFDB pieces are going to be diagonally opposite to each other. In this case, what we're always going to do is to, well, let me first solve the corners. What we're always going to do is to do either an M or an M prime that would move the DFDB piece that is not connected with the center. In this case, it's this DFDB piece on the top. So like here, this is my DFDB piece, this is my other DFDB piece. This one's not connected to the center. So I'm going to do either an M or an M prime that would keep this on the top. So in this case, it would be an M prime to keep it on the top. It would not be an M because that would put it on the bottom. So it would be an M prime. And after doing either M or M prime, we're always going to do an U2. And then we're supposed to have like a line here and also a big chunk here. So we're going to do either M or M prime again to put this line on the top or the chunk at the bottom. So here it would be an M prime to put the line on the top and the chunk at the bottom. After that, we're just going to solve the cube with U2 and M2. Yeah, that's the first case that could happen. This one is a bit different, but it's in the same kind of category. If we do an M2 U to solve the corners, the DFDB pieces are opposite to each other, but the DFDB piece that is not connected to the center is this one. So you want to move this to the top, with either M or M prime. In this case, it would be an M to move this to the top. And we're going to always do a U2 after either the M or M prime. And then move this chunk to the bottom or this line to the top, which would be an M prime in this case. And then solve the cube with U2, M2. There are more cases like this, but they're on the back now. Yeah, this would be one of them. So here, the DFDB piece that is aligning with the center is on the back. And it's not matching, so we're going to solve the corners. M2U to solve the corners. They're opposite. So we're going to either do a M or M prime to keep the DFDB piece that is not connected to the center, which is this one, on the top. So here would be an M to keep it on the top. And then we're always going to do a U2. Now we put the big chunk at the bottom. So that would be an M in this case. And then U2, M2. This is the last case. Yeah, so we have a non-matching center case again. It's on the back. And we solve the corners. M2, U, solve the corners. The DFDB pieces are opposite to each other. We do either an M or M prime to move the DFDB piece that is not connected to the center, which is this one, not this one, to the top. So that would be an M prime. Move this to the top. Always going to do a U2. And then move the big chunk to the bottom. In this case, it would be an M. And then U2, M2. Yeah. And finally, the non-matching center cases when the DFDB pieces are gonna end up stacking on top of each other after we solve the corners. So if we solve the corners here, they're stacked on top of each other. Whenever this happens, no matter what, you're gonna always do an M2 U2. After doing that, you're gonna be left with a case that we covered before with the matching center cases, and you're gonna just solve it the same way that you did. If you remember, this case would be M prime U2 M prime. For this is also a stacked pieces case, because if we do an M2U to solve the corners, the FDB pieces are stacked on top of each other on the back. So we're same thing, gonna do a M2U2 always. This case, if we remember, it would be a M U2 M prime to solve. Now, both of these cases are with the DFDB pieces stacked on the back. Here is a case where it's going to be stacked on the front. So we know it's a non-matching center case. We're going to always solve the corners. M2U, solve the corners. Now the DFDB pieces are stacked on top of each other on the front. So still, we're going to do M2U2. But this time to solve this, if we remember this case, would be M U2M. And finally, there's one more case. So here it's also going to be stacked on the front if we solve the corners. Solve the corners, they're stacked at the front. Always going to do an M2U2. Now we have this, which is what we've seen before, M prime U2M. To predict these cases, so for the opposite DFDB non-matching case, you're just gonna keep track of where these DFDB pieces are gonna end up after you solve the corners, and then just predicting which DFDB piece is gonna be not connected to the center. So if this one is white already, we do an M2, I know that's going to become yellow, so this one would be the non-connected DFDB piece. For this, I know that this is going to end up being the non-connected one, because if I do an M2, this is going to be white. These are not going to be connected. So yeah, you're just going to bring this to the top and proceed solving it using the method that we talked about. So yeah, for the opposite DFDB cases, you're just going to keep track of where they are and what the center is going to be. For the stacked, bear with me, I don't have the fourth cube. Yeah. So these are all the possible stacked DFDB cases, and they each look differently. So personally, I just remember what they're gonna be like, what they look like, and then I just know that what I'm gonna need after doing the usual M2U2. Yeah. Just some additional tips. So in this video, I know we only covered the M2 insert to finish up 4B. However, I do acknowledge that most people are gonna not just use the M2 insert. For example, in this case, we can do M prime U2M to solve 4B. So with these different kinds of inserts, we're still gonna keep track of DFDB pieces, but we're just gonna pay attention to like how these moves specifically influence where they go. in this case specifically, my other DFDB piece is already on the bottom there. I know that because I can see the front. It's not in the front, and it's not on the top, so it must be on the back, which it is. And I know that the center at the back is orange because the center at the front is red. And I know that since that center is orange and this DFDB piece is orange, that means the other DFDB piece is red. So red and orange would be a non-matching center case. And our M prime U2M to solve this 4B is not going to change anything on the back. So I know that I would 100% get a non-matching center case. M prime U2M. And we do get a non-matching center case still. So we solve the corners. And this is the lonely DFDB piece. So we're going to do M prime to keep it on top, U2, M prime, put the chunk at the bottom, U2, M2. Yeah, there's a lot of these ways you can infer the colors of the centers on the back, whether or not a DFDB piece is on the bottom, and just in general where these DFDB pieces are. And these intuitions come with more practice over time. And once you've done enough solves with DFDB, you're naturally gonna be able to predict these fairly quickly and be able to do cycles without any pause. Because with DFDB, you can keep track of things during 4B instead of compared to like B recognition. You have to actually solve 4B and then look at the stickers of the front and the back. So yeah, it gives you a lot more time to think about what case is gonna be next. So that's how you utilize DFDB to its full potential. And yeah, thanks for watching.